we're going to go over this interesting simulation with a lot of different elements, pretty abstract, kind of like almost kind of like a microorganism looking type thing. So let's just kind of talk about the overview. So we have the cloth sim of these I don't know, sacks, and we have the spheres inside of them interacting with the outer layer, and you can see it kind of shrink wraps them over the first part of the simulation, and then they break out of it at the later part. And then we have these cloth strands connecting the two, and then a hair sim on top of those strands. And you can see, if you look closely, the hair strands are actually interacting with the cloth in the scene. So, we do our best to make everything, interact and not have any, penetrations of the hairs through the cloth and everything. So we'll go over all the different elements of how to make something like this, and hopefully you just get other ideas about how to make various elements that you can simulate in Cinema4D interact with each other, kind of like the first video that I did. So I'll just try to rebuild everything, from scratch, so we can see how that process looks like. Okay. Let's delete that. So the first thing we'll do is create our cloner for our spheres. I tend to switch the sphere type to icosahedron or hexahedron to get more even geometry. I think icosahedron tends to work the best for simulation, just because the geometry is so evenly spread across the face of the sphere. And let's bring this in. Let's say something like that. And then we will vary the size of the spheres with a random effector. So one thing though, when we sometimes, well, maybe not in this example, but sometimes when we use the random effector for this scale, we get some interpenetration of the objects, which for simulation we always want to avoid any initial interpenetration of the objects, because they'll stick together or they won't collide correctly, and it just causes issues for the simulation if they're starting in that position. So one thing we can also try to do is use a push apart, but set to scale apart. And this will scale them apart by a certain radius. So if we use our random effector and then our push apart scale apart, we can have random scale and then also create a distance that they'll stay away from each other. And we can increase or decrease that radius or the effect strength to get enough spacing in between the spheres. So I think that something like that will be okay as a starting point. We can also change this random mode to noise, and then change the scale of the noise if we want to mess with, how the randomness is distributed through the simulation, or through the cloner, I mean. Okay, that should be fine for now. We don't need that to be a child of the random effector. We'll build an outer wall around this cloner as well. So let's make that X-ray so we can see through it. Yeah. Okay. As long as it fits around them all. It looks like maybe we have a couple that might be poking through, so we'll just add a little extra space just in case. Okay. That should be good. And for the cube, we will want to add some more segments to it because we're going to be simulating it like cloth, so we need it to behave like cloth, and for that we need a lot more geometry to work with. So something like that should be okay to start with. Let's try something like that. Okay. So now for our cube, let's add cloth tag, and for our cloner, we will add a balloon tag. First things first, we don't need gravity in our scene, so we'll press Control D, Simulation, go to the Scene tab, and we'll set the gravity to 0 because we don't need that for this scene. And then we will go back to our balloon tag on our cloner. And what we're going to do is we're going to change the balloon settings a bit. Let's try to increase them quite a bit, and let's just get a sense of how our simulation is running with those settings initially. Okay, cool. So we can see we're getting some good interaction and some good inflation of our spheres and our outer fabric. If you want to, you can even one thing that I did in the other one that may or may not be necessary is I played with the target length of the cube, so the outer shell would shrink over time to kind of shrink wrap the objects inside, which is, if you need to shrink wrap something or create an effect like that, this is a really easy way to do that by animating the target length. So we can start it with a target length of 100 and then go to frame, let's say 48, and let's set it to 80 and set our keyframe, and then you'll see, so this, now our cloner objects will be expanding and our outer object will be shrinking. So that should give even more of an emphasized shrinking effect. So in this one, you maybe can't see it as much, but it is even more tightly wrapped around those spheres and kind of holding them in all together more tightly even. If we tick that off, you can see that it is a very tight wrap on those spheres. Let's again see it without the animations, just because in this case maybe we won't need it. So we'll go to animation, delete track, and let's play it again. So I think we'll still use it because I think it'll help with the tearing effect later. So we will actually press Control Z to add it back in. That'll make sure everything is very okay. So that part is set up, and then we can just clone these two objects. and then we'll say top, and we will say bottom. Okay. So we can move this up to about there. And then let's just make sure everything's working before we move on. Okay, great. So yeah, everything is working, and we have a little variation in the way they look, even though these are the exact same settings. If we wanted to, on the top, we could hide this and go into our cloner. We could change it to another random effector and switch up the seed so that our noise affecting the size of the clones would be different. I don't think that I'll need to do that in here in this scene, but if we did want to do that, we would just create another random effector, turn this one off, and add that in. So we would, turn this off, add in a new one, set it to effect scale, and then go into our effector, and we could change the seed, or we could set it to noise again and just change the scale to something different. So that's how we would do that. And if we look back on our cloner, we have the second random effector affecting the scale of the sphere clones. So that's fine. And now we have to add the connections between these two. So again, what we will do is we'll just create planes and then clone those. Let's set these both to X-ray so we can see through them again. And so for this situation, it is actually okay if our connector pieces go through the cloth geometry. So these two pieces of geometry, it's okay in this situation if they go through. And you'll see why in a second. And it has to do with the way the cloth belt system works, because we actually need points that will kind of stick to the geometry we're belting it onto. And so only for cloth belt type situations would you want to allow any kind of like penetration between them. But in that case, it should still work, even if they are intersecting initially. So let's throw that in a cloner as well. And we need to reduce the distance. I think that's the number that I started with. Seems like an okay number. And then we will add another cloth tag to these. And we will add a cloth belt tag as well. So with the cloth belt, we need to tell it, okay, first, what object are we belting it on? So for us, we're going to belted on this cube. This cube 1 was the first thing. So we will go belt on cube 1. Okay, great. So that's set up, right? Let's play our animation. And just looking at it, it looks like it might be working, but if we get in closer, we can see they're not actually attached to the geometry and staying in place. So that's because there's another step we need to do before the cloth belt will work. So we'll go back into our plane or our cloth belt tag, and we actually need to set points. So we need to select points and set them to kind of activate them. So for this, I believe we need to have this geometry be editable. Then we'll go into points mode, and we will go brush select the topmost points, and then set those as our cloth belt points. And you can see, so this still isn't working. I wonder if we need to convert this cloner to if we need to convert the cloner to geometry. Let's take a look back at the first example. So our cloner has been converted to geometry. So that's one thing that we can keep in mind. And then we can see the little connections between the points of the cloner and the object that it's belted on. Okay, so when we click show in points mode, we can see all the points that are belted on. So that looks like what we were trying to do. So we'll just convert the cloner to geometry, and then we'll try again to make sure we can get this set up properly. Okay. So I guess for this to work, the object you're belting on needs to be an editable object. So we had to convert our cube, our top cube, to editable geometry before the belt would work. So that's something to keep in mind. And that for us, this is fine because we were kind of finished with setting up our cubes anyways. So that's fine, but just something to keep in mind if you're wondering why that isn't working, and a reminder to just make sure that it's set up the way you want before belting things onto it. So now when we play, let's cross our fingers. Okay, so yeah, you can see it's fully attached to that geometry and sticking along wherever it moves to. Which is great. And you can kind of see as the turbulence pulls these along too, they're having a mutual influence on the outside of that kind of mesh as well. So I think it'll be really interesting once we connect to the bottom part as well. So we'll just repeat that same process, right? So adding another cloth belt tag, and so it'll be the bottom cube. But again, we want to click on that cube and convert it to editable geometry first. And then we will go to our second cloth belt tag and drag that in. And then we'll go back to our cloner, points mode. And let's go in the front view, select all of these, let's click on this. So the one thing to look out for when you're selecting is make sure that visible only is not checked on for this, because we want to select all of the points, even the ones behind these front points. So looks like we got everything. And then we'll go back to our cloth belt tag and click set. And you should have draw on so that you can see when it creates the connections, they will turn yellow. And so you'll be able to see that it is working. And we're not going to go over these more advanced controls right now, but these allow you to have more control over the belting and how it happens. So just know that there are some more advanced options for you in this, but for us, this is going to work just fine. So now our belt should be fully working on those clones, and we should kind of see how this is beginning to really take shape. So cool, we can kind of see how we're getting that pull between the two places that the cloth strands are belted onto, and you're just getting some really interesting interactions between the two of them. So the next thing we can play around with is adding hair simulation into the mix. So yeah, it crashed there for a second. I think it was because we had our timeline set beyond 0 when we added the simulation. So I think that just something was going haywire. So just before you add your hair, just reset the timeline to 0, and hopefully your computer won't, your Cinema4D won't crash. But so we've added the hair onto this top cube, and let's just check what that looks like initially. I also decreased the length of the hair a little bit. Maybe we can make it a little longer just to visualize things a bit better. So let's look at that. So yeah, we can see our hair is following the geometry that it's rooted to, and it's hanging down, looking kind of cool and shaggy. But let me see if we can get a good visualization of this, because, well, it looks like in this case, the simulation may be already doing a pretty good job of preventing any hair from intersecting the original mesh. But if we need to, we can add hair colliders to the scene as well. So if we wanted to, 100% make sure that no hairs were penetrating the object, we could go cube, hair tags, hair collider, and then we could run it back and see how that changes things. So it still looks like, yeah, we're definitely, well, maybe the viewport is just not updating, so just the viewport might not actually reflect exactly what's going on, because when we stop it, we can see these are definitely being stopped by the geometry. So if you want to add the hair collider tag, just make sure you do that to prevent intersections on the geometry. So it might add a little simulation time, but if it adds, to the realism of your scene, it's definitely worth it. So hair dynamics, they come with their own material. They come with their own dynamics and forces tabs. So you will have to add those in specifically. You had to specify in this. It's not just going to accept the scene settings. So that's why it's still being affected by gravity, which, it looks kind of cool that it's being affected by gravity, but the other elements aren't. So, just whatever looks cool for you. We'll turn it off, and then we'll add into the forces tab, we'll add our turbulence. And then let's check it again. So now this will be just a mix of turbulence and following the geometry that it's rooted to. So it just kind of looks more like it's just following the parent geometry. Right? So we could add that to, this, this one and this one, or we could try this middle section as well. So let's do that. Let's go to guide, link, and select our cloner instead. I guess let's just create a new hair object. Select our cloner. And you can see one limitation that I've found is that it will, with flat objects like our plane, it will only scatter in one direction. So you can see it's coming out only one side. And I haven't really looked into it. I'm sure there's probably a way to fix that. But for us, especially if we're viewing it from one angle, it's not going to make much of a difference for us. But again, we'll go to the dynamics and add in some forces and turn off gravity. So you can see this, this is kind of the look that I went with because I liked just, the kind of chaotic motion of the hair following the strands in the middle. So either way, scattering it on whatever simulated geometry is going to give you cool results, because it's going to follow that geometry exactly. And then you also get the, simulation of the hair itself. So that's kind of the basis of the effect. And, we can tweak things as much as we want to get whatever kinds of different effects we're looking for. But we can quickly go through some rendering as well. Let's change this to 1080 by 1350. And for this, I think I used a sun and sky rig. So let's do that. See what we can kind of get with that. And one thing too, if your computer is struggling with any of these simulation sections, you can always cache out. Like you could cache out the simulation for the cloth and the balloon spheres, and then have that all cached out, and then simulate your hair on top of it. So that would just, that could be a stage of optimization for you if it's struggling to run everything all at once. So here is our starting point for rendering with the sun and sky rig. So let's see if we can get a little light on our hairs as well. Okay. So that looks, kind of cool right now. We can, on our hair, we have lots of options that we can change about our hair let's get rid of this extra hair material on the hair material itself. So we'll double click and we can go in and you have all these different options. Let's see what could be a cool one. Maybe this one. This kind of looks cool. This gradient that they have built in. It depends on how many hairs you have and everything, what the correct thickness will be for your scene. You can also get some cool effects with, large thickness and lower hair count if you want to simulate like leaves or interesting like kind of plants or other abstract things that aren't exactly supposed to look like hair. But and for this shot, since we're farther away too, this might not matter very much to us. So we can try to reduce this by a factor of 1/2. And it looks a little finer and everything. We can also play with things like frizz and kink to give it a little bit more character. We can change the amount and variation. So if we set this to 100, it's going to be, pretty wild looking. But we could add a little bit of it to the scene, and you can add variation. You can also change the amount along the curve. So at the base, it's going to be 0, and at the tip, it's going to be 100. Same thing with kink. These are just adding kind of character to the hair. And for us, I don't think we need both of those. We just want a little bit of breakup of the profile of the hair. With density or with clump too, it does exactly what you'd think. It makes the hair clump up into smaller groups. So let's see what it looks like if we do 100. Doesn't look like we can see super well what's happening. So, that's the count is 100%. So let's go to clump 100%. Okay, there you go. We can see, it kind of bunches them all up into these little tufts, which is a cool look. And you can change the radius or twist of those. So, we could go 180 and radius of 10 maybe. And then let's reduce this to maybe 20. We get some interesting clumping effects, that aren't, they're still pretty over the top. And it's just fun to play with these things, right? Like, and see what kind of effects you can get. And yeah, like to me that looks cool and adds some just more character to the hair as it's going through the simulation. And yeah, there's all kinds of different effects that you can add. Transparency to make the hair more translucent when sunlight passes through it, or any light passes through it. But that'll increase the render time, and in this case, it doesn't change the look very much for us. So we're gonna leave it off. So I think that'll be fine for now. And I kind of like this color scheme, so we'll just kind of go with that color scheme as our for our whole render. So let's get into that. Let's create ourselves a couple more materials just so we have a couple things to play with. So for our top and bottom, we're going to look at our cubes to have the same material. Let's just change that to something we can see through. And then for our cloners will also add those to have the same material. And let's go into our cloner. Okay, so on our random effectors, let's also have them use color. So if we get rid of the materials for a second, we should be able to see that that these are being attributed a random color based on the effector. So let's do the same thing with this cloner, or this random effector. And in this scenario, our colors are all very dark, so we can change blending modes, but as long as we have a random distribution of the colors, we should be fine. And if we need to, we can change things at the shader level too. So we just wanted to assign some randomization to the color, so we can access that on the shader level. So we'll dive into our shader and grab a color user data node and set that to MoGraph color, which that'll give us the colors that are on the spheres from the effector. So you'll see it's the same look as what we had from the random effector. And let me turn off these two so we can see those better. So yeah, everything is pretty black right now. So if we plug it into a ramp, go into a ramp, input, alt input, color. We can see we're mostly getting black instead of a distribution along the whole distance of the gradient. So what we can do is we can use a color change range node, is one solution to this problem. And then we can change the minimum and max values. So we can see that if we change that, we get all black. And so if we change the max, we can reduce the spread of the whole range. We can change this to, to get whatever kind of spread we want for our colors. Okay. But we probably, want to have some spread between black and white and not have everything the same color. And yeah, this might not be the optimal way to approach solving this problem, but it is, it's just one way to do it. Okay, so now again, let's load in our flame preset and see what we can get that. And once we do that, we might want to also change some of these around again. Just so we have, whatever distribution we like. Okay, I think that's okay for now. If we end up using those colors, it's nice to have that color set up, ready to go. And after our ramp too, if we want to modify the color a little bit, we can use a color correct node as well. So we have those initial colors set up. And something that, we can test out too is things like piping this color into the subsurface color and trying to see what the subsurface looks like if we use that instead. And we can play with the scale value to have light penetrate farther into the spheres. And we can play with the roughness value too to see whatever looks best for our scene. I think that's an okay start to things for now. So if we turn back on our cubes, you can see it looks kind of strange because these are behaving as if they are solid pieces of glass right now, which is not accurate to what is in the scene, because these are supposed to be kind of thin sort of sheets of cloth around this. And oh look, I totally forgot we are using a noise for our random effector, so that'll change the color each frame or so. So let's go into our effector, and instead of that, we are going to want to use random instead, because having it change each frame is not going to work for us. Or we could make another random effector that is specific to color. So that's another way to approach that. Just make a new one and only have it affect color. But for us, let's just see if this works. We'll have to adjust our push apart effector though. So nothing's penetrating still. Okay, now they're all staying the same color. Okay, so we were talking about the kind of the outer layer looking like solid glass, right? And once it expands, maybe it could look okay, but for those initial frames, it just doesn't look right, and it still kind of doesn't look right. It looks weird that these are being like you're looking through a thick glass surface. So one thing we can do is, instead of using the standard settings, we can go into thin walled under geometry and check that on, so that it operates more like a thin sheet of a see-through material rather than a thick solid piece of of glass or something. And then we can play with whatever settings we want to play with in terms of roughness. We might want to increase it so it looks more like there's a coating around it. And we could add maybe a bump map. Let's see what a noise looks like on here. For me, I really like Poxo. It's a really fun, detailed looking noise. To increase the scale a bit. And then we can use any black and white texture in bump maps as a height field, and that'll read in just fine. And if we put the noise back on, and if I play this forward, we should see that the noise follows the geometry, because these objects that Cinema4D generates, like the cube we used, are already UV mapped, so we don't need to worry about our textures moving around or anything like that. So that's just something to keep in mind. Our textures are going to work perfectly out of the box with those objects that Cinema4D generates. So that's in bump map now. We can't see a whole lot because we're kind of zoomed out, and also our denoiser is on. But but you can start to see some of these little imperfections along the surface. And, once you take a look at it with the bucket rendering or your picture viewer rendering, you might realize these are way too high. So you can just turn down the height field, height scale if you want to. But for our visualization, we're getting good visualization of that. Looks kind of organic and cool. And for our hair, maybe turn up the brightness. Maybe we do turn on the transparency. Let's try to see what that looks like. It doesn't really look very different, does it? In this case. Okay. I mean, that looks okay for some just, initial kind of look development stuff. We could spend hours on making this look however we want it to. One thing that I kind of forgot about was we should go over how to make these tear, along the simulation. That's one part that we wanted to add on to it. So let's turn off materials. Put on X-ray again so we can see that. And let's jump out of the camera here. Also, you can see these indicators of where our camera is. We don't need those. So if you press Control V and go into Save Frames, that's what these are called. You can turn them off, or you can just adjust the opacity. And if you're wanting to set up your shots, you can turn this all the way up and just see what your camera's going to see. So for us, we just don't need them right now. So on our cubes, we want to have tearing enabled. So with tear enabled on the default setting, let's check out what that looks like with our current setup. Let's save our project real quick. So you can see already things are kind of getting a little bit slow when we go to simulate things. So at this point, it might be good to turn off the hair and then set up our simulation and then cache it out and then have the hair come back on once it's all cached out. So I'm going to turn off the hair, and we'll see we get a good speed boost from just turning off the hair, not having to calculate that. But it is still not super fast for me right now. Okay, I just had to troubleshoot a little bit there. When I changed the segments of the sphere, it kind of it made this simulation do some funky stuff. So I just turned them back up, and increased the turbulence strength and scale, and I set the made sure to set the tearing so it goes from 200 to 110 over the course of a little less than a second. And you'll see that because I cached out the simulation now. So our cloth and balloon sim is cached, and here's what we have. So you can see, there's a good amount of turbulence, and then when the tearing goes down, right here is when it starts to drop. You can see there's some expansion, and then it starts to break. And that's something that I've seen in my tests is when you animate the tearing past value down, it does tend to do this kind of like expansion and then tear. It doesn't just tear immediately. Maybe if this went faster, it would. So maybe that would be something to test is animating the value just over the course of a frame or two. And you could, maybe get a little bit more sudden of a tear. So let's add in our hair simulation on top of that now. So now everything runs much, much quicker with the main sim cached out. And so we have now, let's take a look at it in the render view as well. And so we can see we have our hair and our torn outer layer, and our inner sphere is coming out of the kind of sack, whatever you want to call it. And for our hair, maybe it's going to look chaotic because it's moving so much, but we can adjust. Maybe we can get rid of the clumping for this. And we can go in and change the shading. We could add bump maps to our inner spheres to make them look a little bit more organic or things like that. But overall, this is kind of the main effect, and kind of where I got to when I was playing around with this kind of setup. And yeah, I think it it looks pretty cool. It's a pretty fun way to see how you can layer like hair on top of another simulation. And we could try simulating our hair on top of maybe one of these. And doing that, we get an entirely different look. And it's just fun. It's just fun to play around with these things, see what kind of different looks you can get, and then make changes. And some reason this is not following the geometry after a certain, wait. Looks like right where I turn on the tearing, it doesn't work for some reason with the hair. Okay, so if you turn on the hair collider, if you add the hair collider tag to that, it should work. So there we go. And let's keep going a few frames to see what it looks like with some of the tearing going on. Yeah, something still isn't right with this. So if we wanted to correct this, what I might do is cache this out as an Alembic file and then bring it back in and then simulate the hair on top of that. And I think that would, probably solve the issue. But yeah, right now it's not following the geometry completely correctly right now. But, again, it's just another thing, another test we can do. So I think, yeah, that's where I'll call it for now. And if you have questions, let me know. And I hope you enjoyed this one. Yeah. Bye.